Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 1st, 2025, just yesterday. This paper reports a code-driven pipeline that boosts learning effectiveness by 40% over direct code generation, producing videos that rival human-crafted tutorials. The paper is titled Code2Video, a code-centric paradigm for educational video generation. And as we will see later, the implications for educational content creation are quite significant. In short, a tri-agent system called Planner, Coder, and Critic generates executable Python animations, then validates them on the MMMC benchmark using aesthetic judging, code efficiency, and a knowledge transfer test named TeachQuiz. Also, the author shared a GitHub repo. You'll find the full Python code for their agentic, Manim-based pipeline, set up via requirements, and an API config file, plus prompt templates and JSON topic lists. There are shell scripts to generate single or batch videos, example outputs, and evaluation scripts for aesthetics and teaching quality. Figure 1 shows the big idea and workflow, highlighting why code-centric video beats pixel-based generation. On the left, pixel-driven synthesis struggles with control, while on the right, executable Python enables scalable, interpretable, and controllable outputs. The lower left panels describe 3 agents. Planner organizes the flow, Coder turns storyboards into Manim animations, and Critic refines spatial layout. The lower right panels summarize evaluation on MMMC, including TeachQuiz, a relearning test that checks whether watching the video restores concept accuracy. Figure 2 shows the MMMC overview with 3 panels that map the dataset scope. The left donut groups content into 13 subjects, and ring width indicates video duration, which means thicker arcs mark longer total time. The middle word cloud highlights core ideas, giving a quick sense of emphasis across topics. The right bar chart reports average topic length by category, with the overall mean around 6.5 words, so prompts stay concise. Alright. Figure 4 illustrates how the system turns a learner query into an executable, educational video. This figure presents a 3-agent pipeline that plans content, writes Manim code, and then critiques layout using a visual anchor prompt, which is a grid that tells the model where to place objects. The left block shows the planner preparing outlines, storyboards, and assets. The middle block shows the coder generating and fixing code, so temporal flow stays consistent. The right block shows the critic adjusting positions and rendering clear section videos. So, Table 1 compares efficiency, aesthetics, and teaching quality across human videos, pixel models, direct code, and the agent pipeline. The main takeaway is that pixel models score lowest on layout and logic flow, because they cannot reliably render text and time animations. Direct code generation improves aesthetics and quiz accuracy, showing that executable scenes give stronger control. The agent pipeline ranks highest overall, with the Claude Opus variant reaching about 88 on average aesthetics. Time stays practical because parallel section synthesis cuts runtime versus serial generation. Okay, 2 takeaways stand out. Using executable code as the substrate gives precise layouts, coherent animations, and about 40% higher learning gains than direct code. And the Planner, Coder, Critic trio, with ScopeRefine and visual anchors, makes the workflow efficient and auditable. The broader implication is scalable, reproducible lessons that remain editable programs. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.